Welcome student. In this session we are going to learn about pure virtual function and abstract classes in C++. This is very important topic in object oriented programming because it helps us design flexible and scalable systems. Before we start, recall what we studied earlier, inheritance and polymorphism. Today's concept builds on those ideas. Think of this session as moving from basic inheritance to advanced design concept. By end of this session, you will be able to understand what an abstract class is, write programs using pure virtual functions, understand why abstraction is important in real-world system. Let us begin with the basic idea. What is an abstract class? Let us understand abstract class is very simple way. An abstract class is a class that cannot be used to create objects. That means you cannot write animal space a semicolon. Instead, it is used as base class for other classes. You can think of it like a template or blueprint. For example, think of a vehicle. Vehicle is a general concept. You don't create vehicle object directly. Instead, you create car, bike, bus. So, vehicle is abstract class. Car or bike are derived classes. The main purpose is to define what a class should do, but not how it should do it. This will help in designing clean and reusable programs. Now let us understand the core concept behind abstract classes, the pure virtual function. A pure virtual function is a function that is declared inside the base class, has no implementation. The syntax is virtual space return type space function name equal to 0. This means the equal to 0 is very important. It tells the compiler that this function has no body. This means the derived class must implement this function. Think of it like a rule or contract. For example, if you define a function draw in shape class as pure virtual, then every derived class like circle or square must implement draw. So pure virtual function enforce implementation in derived classes. Let us understand this example step by step. We have a class animal. Inside it we define virtual void sound equal to 0. This makes animal as abstract class. Now we create another class dog which inherits from animal. Dog provides implementation void sound cout dog box. Now in main we create object of dog space d, then call d dot sound. Important point, we cannot create object of animal. This example shows base class define function, derived class implemented. This is an extension of abstraction. Let us clearly understand what is happening in this example. Animal is abstract class because it contains a pure virtual function. Sound is declared but not defined. Dog inherits animal and provides its own version of sound. So dog becomes a complete class and we can create its object. This concept ensures that every derived class must define its own behavior. This improves program design and avoids incomplete implementations. So always remember, abstract class is incomplete, derived class completes the implementation. Let us look at more advanced example. We have an abstract class shape with the virtual void draw equal to 0. Then we have circle class, square class, both override draw function. Now in main we use a pointer shape s. Then we assign s equal to ampersand c. We call s arrow draw. It calls circles draw. This is called runtime polymorphism. Even though pointer is of type shape, it calls the function of actual object. This is very important concept in C++. Let us now understand why abstract classes are used. First, they enforce a common structure. All derived classes must follow the same function pattern. Second, they improve code reusability. Common logic can be written once in base class. Third, they support polymorphism. We can use base class pointer to call derived class functions. Finally, they help in large system design. In real-world application, abstraction helps organize code properly. So abstract class are not just theory, they are widely used in software development. When to use abstract class? Use abstract class when multiple classes share a common interface. For example, shape, arrow, draw. Every shape has draw function, but implementation is different. Similarly, vehicle, arrow, start. Car starts differently from bike. So abstract class define common function names, while derived classes define actual behavior. This avoids confusion and maintains consistency. Sometimes we want to ensure that every derived class implements certain function. For example, payment system. If a class does not implement it, it should not be allowed to exit. Abstract class helps enforce this rule. So they act like a strict guidelines for developers. Abstract class are very useful in runtime polymorphism. Shape star s equal to new circle s arrow draw. It calls circles draw. This allows writing flexible programs. We can change behavior at runtime without modifying code. This is heavily used in game development, GUI system, simulation software. So this is very important concept. Abstract class can have some fully defined function, some pure virtual function. This means we can use we can reuse common logic and allow customization when needed. For example, a base class may have login logic, but derived classes define different authentication methods. This gives both flexibility and reuse. Abstract classes are useful in modeling real-world applications. For example, animal is abstract, dog and cat are real classes. We don't create animal directly. Similarly, employee, manager, engineer. This helps in designing clean hierarchical system. It matches real-world thinking with the programming. Abstract classes can help reuse code duplication. Common data and functions are written once. Derived classes reuses them and add their own behavior. This makes code shorter, cleaner, easier to maintain. This is very important in large applications. To summarize today's session, we learned what is an abstract class, what is a pure virtual function, how inheritance and polymorphism work together. Remember, abstract class defines structure, derived class provides implementation. Practice writing small program to understand this better. In the next session, we will build more advanced example using these concepts. Thank you.